Hello everyone. We already discussed that resonance effect, electromagnetic effect, inductive effect. Then now we discuss last effect that is hyperconjugation. We we already known about resonance. This hyperconjugation is also similar to resonance. Similar to resonance. Therefore, before studying this hyperconjugation, we must know about resonance. That is, resonance is nothing but delocalization of pi electrons of the conjugated systems. Delocalization of pi electrons of the conjugated systems is resonance. We know that in benzene, sometime that bonds located at that between the carbon atoms, for next fraction of second they are located in between next carbon. Such type of delocalization means they changes their position time to time. Such type of delocalization of pi bonds in conjugated systems is resonance. Then what is hyperconjugation? Remember that hyperconjugation is special type of resonance. It is special type of resonance in which C alpha H covalent bond is participated in delocalization. This is only definition. Remember, hyperconjugation is special type of resonance in which C alpha H, that is hydrogen which is located on alpha carbon, that is known as C alpha H, carbon hydrogen covalent bond. But which carbon hydrogen bond? That hydrogen which is present on alpha carbon, alpha to double bond, that is known as C alpha H. Therefore, hyperconjugation is special type of resonance in which C alpha H covalent bond participated in resonance or in delocalization. That is known as hyperconjugation. See here, for example, C alpha, that carbon which is um, nearest carbon. Alpha means alpha, beta, gamma, delta. This one is nomenclature system. That is, alpha means 1, beta 2, gamma 3, as like that. Alpha is 1. That is, nearest carbon to that double bond is nothing but alpha carbon, and that hydrogens attached on that carbon are known as C alpha hydrogens. That sigma bond shown here is participated in resonance. Here mistake is there in second structure. That bond must be disappear here. That one is shifted to in between this carbon hydrogen bond. In first structure is shifted between carbon. That means this hydrogen is non-bonded actually, but they shown here by mistake bond. Bonding is there, but remember that this bond is absent in second structure. In this one is shown correct. That bond from this carbon hydrogen is migrated towards in between carbon, and therefore initial pi bond is shifted, that pi electron shifted on that carbon. Therefore that one of the carbon acquire negative charge, and that hydrogen, because of loss of electrons, that hydrogen acquire positive charge. Then in next fraction of second, adjacent carbon hydrogen bond come here and takes the place of that initial carbon hydrogen bond. Uh, such migration of that carbon hydrogen bonds which are in conjugation with the carbon carbon double bond is known as hyperconjugation, and here that one is hybrid structure is shown here as. Then it is this one is a question that hydrogen which one is here empty, that one is non bonded, only shown here as a H plus, no any bond between carbon and hydrogen. Then why not that migrated to other places? Why that remains as it is on same place? Because this movement of bond is so fast that before migration of that hydrogen ion, that another electrons coming there and form the bond between that hydrogen and carbon. That means that hydrogen H plus have no time to move from their original place, therefore that remains in their original place, and this migration bond movement is possible. Because of hyperconjugation, alkyl groups, we know that alkyl groups shows electron donating tendency, electron releasing tendency. Why alkyl groups shows this tendency? Because of hyperconjugation effect. Alkyl group shows electron donation power or electron releasing power. More the number of C alpha hydrogens, more number of canonical or resonance structures are possible, and more is the stability. More are the resonance structures. For we already known that this hyperconjugation or resonance, when there is delocalization, that takes place charge separation. If the species is charged like positive or negative, that is cation or anion is there, that cations and anions both can be stabilized by resonance, by hyperconjugation also, and this stabilization is more if that resonance structures are more the number of resonance structures, more is the stability. Thus here, when that any ion, positive ion or any conjugated system, when that have more number of canonical structures or resonance structures, in case of hyperconjugation effect, if that number of C alpha hydrogens increases, number of canonical structures increases and stability also increases. In case of toluene, that is methyl benzene, there are 3 C alpha H. That means that CH3 hydrogens are alpha, that carbon, CH3 carbon is alpha carbon to that double bond of benzene ring, and therefore that one is that hydrogens, 3 hydrogens are C alpha hydrogens, and therefore 3 hydrogens, therefore there are 4 resonating structures. 4 hydrogens, if 3, 4 resonating structures. If hydrogens 5, 6 resonating structures, as like that. Then there is difference between here. Some difference points are some points are given which shows difference between resonance and hyperconjugation. All of you study that hyperconjugation and resonance thoroughly, and that see here points which shows difference between that two effects, which are simple points. We know that resonance takes place uh, when double bonds are conjugated, or lone pairs that are conjugated to double bond, while hyperconjugation takes place when C alpha hydrogens, that is covalent bond, is in conjugation to double bond. Resonance is delocalization of pi or non-bonding electrons, while hyperconjugation is delocalization of sigma electrons. In resonance, that contributing structures, covalent bonds are present between all the atoms, while in hyperconjugation, the contributing structures, covalent bonds are absent between some atoms, some pair of atoms. That is in here, see here, carbon hydrogen bond is, covalent bond is absent for fraction of time. Mm. In resonance, hybrid structures contains partial double bonds. In hyperconjugation, hybrid structure contains even partial sigma bonds also. Sigma bond also participate in hyperconjugation. Therefore, that hybrid structure contain that covalent bond also. These are some points which represents that difference, distinguish between resonance and hyperconjugation. Then we discuss here next point, that is dipole moment. Dipole moment. Dipole moment is a measure of polarity of the molecule. Polarity. That poles are formed in molecule, positive pole and negative pole formation is possible in some molecules because of electronegativity difference. There are two type of covalent bonds. Bond between two similar atoms, that is AA, BB, that is that bonds, and bond between dissimilar atoms, AB, molecule consider AB. A and B are not same. Then if that are not same, then what happen? If that A and B are not same, their electronegativity is also different. Then if electronegativity is different, then more electronegative atom pulls that electron pairs towards itself and acquire negative charge, and less electronegative atom, that is electropositive atom, acquire positive charge because of loss of that electron pair that acquire positive charge. Such positive and negative charge poles formation is possible in such type of AB type of molecules, and that is nothing but result of this is nothing but bond polarity and molecular polarity. That type of molecules are polar molecule. For example, HCl. HCl is more electronegative than H. Therefore, that bond between H and Cl is more. That one is attracted towards Cl, and Cl carries delta negative charge, and hydrogen carries delta positive charge. And such bonds are nothing but polar. Such molecule, HCl molecule, is polar molecule. Then in CHCl3 there are some bonds, CHCl3, CCl bonds, that electron pair between carbon and chlorine, that one is shifted towards chlorine because chlorine is more electronegative, and therefore all that three chlorine in CHCl3 are negative, and carbon is positive, partial positive charge, and therefore chloroform is polar molecule. Then what is definition of polarity? That dipole moment. It is measure of polarity in molecule. It is measure of polarity in molecule. Is nothing but dipole moment. Here how they give one definition. See here. Dipole moment is the measure of polarity of the molecule, and it is calculated by the formula, that is dipole moment mu is equal to delta into L. What is delta? Extent of charge separation. Extent of charge separation into L. L is nothing but bond length, bond distance. That extent of charge separation depends on, remember this point, extent of charge separation depends on extent of that electronegativity difference, extent of electronegativity difference between the two atoms, AB type of molecule. Then there is, if electronegativity difference is more, if one atom is highly electronegative and another is highly electropositive, electronegativity of one atom is very high, while for another atom it one is very less, then the charge separation is more and value of delta is more, and therefore value of dipole moment in that case also more. In some molecules, here you consider trans isomer of this 2-chloroethene, that is dichloroethene, sorry. Here trans isomers, two bonds are opposite, and therefore dipole moment of this bond is cancelled by another dipole moment of opposite bond, and therefore dipole moment is here 0. In this case, dipole moment becomes 0. While if same molecule, if we consider cis isomer, then it shows positive dipole moment, that is non-zero dipole moment in this case for cis, while for trans dipole moment is 0 because cancel to each other. Similarly, in case of carbon tetrachloride, dipole moment is 0. Here dipole moment for some molecule is given. Then we discuss here on the basis of all these factors, that is on the basis of electronic effects, that is inductive effect, resonance effect, hyperconjugation, and this dipole moment, we discuss here some properties or characteristic of some molecules in the chemistry. What are consequences of these effects in chemistry? What are the effects of these properties on molecular behavior? We discuss one by one. First effect is acidity and basicity of organic compounds. First effect of all this, we explain acidity of organic molecules, organic acids, and basic nature of organic bases on the basis of that electronic effects. Thank you. We discuss this point in during next lecture.